For the second exercise, we're going to build a search method that returns a list of index positions of items found in a list in case there's more than one. We can return list objects just like we return any other data type. So let's get started writing the method first. So we start out with the keyword static. We're returning an integer list because we're going to search a list of numbers. We'll call the method search. Its parameters will be a list of numbers and an item to search for. So the first thing we're going to do is create two variables, found at and position, but I'm going to abbreviate that to POS. I'll explain what both of those do in a moment. POS is going to store the position we are in the list, and I'll explain why that's important in just a moment. Now we're going to create a new list that will store the items that we found. We'll call it items. As we find the item in the list, we're going to add that index position to this list called items. Now the first thing we're going to do is look for the item in the list using index of. We'll go ahead and use the position, although we don't have to in this particular case, because the default is to start at position 0, but we will this time because we're going to use it again later. Then whatever that finds, we're going to add to the list. Even if it's -1 and didn't find it, we still need to report that back to the user. Now we start a loop. If we found an item, then we want to loop through the list and look again. So the first thing we do is change our position to the position after where we found the first item. So that's found at +1. So if we found an item at position 12, we want to do the next search starting at position 13. Then we perform the search. Found at equals list index of item pause. If we found another occurrence of that item, in other words, if found at is greater than -1, add it to the list. We don't want to add a -1 if we've already found it one time. Only return -1 if we didn't find it at all. And that's what this line will make sure happens. And that's all we need for the while loop. Return the list from the method, and that's all we have to do. So here's a look at the complete method again. And again, we're looking for the item, adding it to the list, whatever we return, even if it's -1. Then, if we find at least one occurrence of the item, then we go into the loop and loop through and look for more. And then when we're finally finished with that, we return the list from the method. All right, so let's write a program to work with that. We'll keep the list short so we can look at the items. Our build list method is only set up to enter 20 items. We could actually modify the method. Let's just do that right now. Let's change this. Int num items. And then up here, where we call it, we'll tell it how many we want. Okay. Then we'll display the list. We'll create a variable to store an item. Prompt the user to enter an item. Get that item from the keyboard. Create a new list. And then, here's something you haven't seen before, assign it the result of the search method. Search numbers for item. And then we'll display found items. And that should be all we need. Because search returns a list, we can assign that return value to a declared but not initialized list. You'll see how it works in a moment. So let's run the program and see how it works. Let's see if we can find an item with more than one. That's why I left it at that. 50 is in the first two positions. So we're going to enter 50, and it found it at 0, 1. All right, let's do it again so you don't think that's magic. I see two 54s, 54 at 8, and 19. That is the last position. Very good. Let's run it one more time. There's three 32s, 0, 2, and 13. And then let's do it with one that's not there. I don't see 100. Returns a -1. As an exercise, you could also take that list and loop through it and display each element that's found. But I'm not going to demonstrate that there. Leave a little bit of something for your imagination and something to work on your own. So to recap, we've written a specialized search method that searches through a list and returns all the occurrences of an item in the list, or a -1 if it can't find it. So that wraps up this chapter on lists. Lists are very flexible data structures, and later in the course we're going to look at another data structure called an array, which is somewhat like a list but does have some differences. But for now, we're going to move to the next chapter where we take a more in-depth look at object-oriented programming.